Assalamu alaikum warahmatullahi wabarakatuh, and welcome to DG Academy. We are starting our sub-lesson 2 under our Essential Series. Within Essential Series, we have first domain, which is hardware. What we have discussed already, enough introduction has been given. So let's start with second lesson. The first lesson was generation of computers. The recording is already available on our YouTube channel. So let's start about the components, computer components. As I told you, do not take it easy. Do not ignore this point, because after 30 years, we have to come back. We have to look at the same portion. We have to look at the component. We have to look at the CPU. Not, of course, we don't have to look at from the very immature eye, but we have to look at from the capacity measurement, future planning, and also from the virtualization point of view. For there are so many aspects we have to look at the hardware computing. So many aspects. Even if you are part of a service provider company, and you maybe if you are a vendor, to fulfill the future needs, to make a proposal, to make a good pricing, to get the pricing from the vendor, you must be very careful about hardware component. So that's why I'm just emphasizing enough that please focus on this point. Okay. So today we are diving into the very fascinating world of computer components, their design, the features, and that modern computers, that's why they're so powerful. And we'll start our component with a holistic view of computing. Remember one thing, whatever we are learning here, all the computers, either it is a small laptop, a palm top, a mobile phone, a computer, a desktop computer, a server, entry-level server, the high-end servers, the high computing servers, supercomputers, they all follow the same mechanism, same layout, same schematic, same. The difference is computing power. The difference is number of components. We stack them to combine the power in order to achieve our target. So the peripherals, the input devices, the output devices, the components, the part of computers, the peripherals, how these components are connected, how external components are connected to our computer, how these components are interacting with our computer, what are the parts of our internal computer. This is what we are going to discuss today, inshallah, one by one. But the high level, I can tell you about our focus point is CPU, which is the central processing unit, or CPU, often referred to as the brain of a computer. The CPU executes instructions and process data. It consists of multiple cores, allowing it to perform several tasks simultaneously, enhancing the power and the performance. From some of you might have seen, okay, yes, we know CPU, how does it work, blah, blah, blah. We have been studying it in our graduation program, or maybe some other computer courses, maybe the hardware. But I would like you guys to look at each and every component from a designer point of view, from a vendor point of view. For example, if I ask you, okay, from right now, suppose you are IBM, you are a Dell, or you are EMC, or you are Lenovo, and you have been given a task. Okay, you have to design a laptop. You have a task to manufacture a computer. Then the way you look at the computer will be changed, completely changed. Right now, you look at the computer as a consumer. That's why you ignore it. But if I ask you, you have been given a task to design a computer, design a laptop. Let's say start with small. Believe me, the way you look at the computer, a laptop, will be completely different. I can challenge you this. This is what we go through. Our mother company, DG Info, we have a project called Native Security. And in Native Security, we actually design 4 component. We are designing our own motherboard, we are designing our own storage, our own CPU, and we are um, developing our own operating system, our own Linux flavor. It's called DGNSOS. Very soon, what we will do, we have, before Corona, we manufacture 100 laptops with the help of our partners, of course, because we don't have the facility over here. But designing part was done by us, and manufacturing part was done by our partners. But very soon we will achieve, inshallah, this capacity and this capability also. Now, if I would like to take you through the same journey, what we are going through right now. If you are designing your own computer, then you will look at these components from a very deep eye. Okay, let's say if I tell you RAM. Okay, let's get back to the the component, otherwise we will miss our 30 minutes. So the function of CPU, the central processing unit, it's a brain. It executes the process, it executes the instructions, it processes the data. How does it work? In depth, we will go through it, inshallah, one by one in the next slide. And RAM is about random access memory, which is about that component temporarily stores data that the CPU needs while performing the task. The more RAM means more performance, because it will increase the capacity. And it actually process temporary data. Why? Because the nature of RAM is to process the data very fast, simultaneously, without slowing down. And you might have experienced that in the past days, your computer is very slow, your game, heavy images, game rendering games are, and you can see the jerks in the screen, and you moving the mouse and you see the slowness, you feel it. Why? Because of the shortage of RAM. The required RAM is, let's say, 16 GB and you have 8 GB. So this is the reason you have slow performance. We will deep dive and we'll see how does it work. Then we have storage devices. We have solid state drives, SSD. We have the traditional hard disk drives. And hard disk drive uses a spinning disk to read and write the data, while SSD use flash memory for faster the data and accessing and retrieval. So in today's world, we are using SSDs. It's more preferred because of the speed and efficiency. Then we have the motherboard. Yes, the motherboard. Why motherboard? If you look at the name of this motherboard, because you will right now, please remember what I told you. Look at the computer from a designer, from a manufacturer, from a vendor point of view. Don't look at the computer from a consumer point of view. This is the quality of DG Academy. We want to see you as a vendor. We want to see you as a developer. We want to see you as a designer of the system. Forget about the time where we spend our energy and time and efforts on someone else's technology. Yes, I don't want to name who is someone else, but you know it. So tomorrow I would like to see somebody from you, somebody from your group, somebody from our WhatsApp group, or somebody from our DG Academy alumni has opened a company or is showing me his own manufactured laptop or designed laptop or his own RAM or his own CPU. This is what we want to see you in coming future, inshallah. The motherboard, it is a main circuit board that connects all the components of computer. It houses the CPU, RAM, and storage, and provides essential connections for peripherals like graphic cards and network interfaces. We'll deep dive, we'll see more things about the motherboard. And then we have graphics card, the GPU. These components are crucial for rendering the images and videos, whether you are gaming, editing videos, designing graphics. So powerful GPU can significantly enhance the visual performance. In old days, where we have black and white screen, the GPU was not there, so there was a built-in GPU within the CPU. But since we have the graphical interfaces, since the birth of Macintosh and Windows operating system graphical user interfaces, then the importance of GPU is increasing. And nowadays we have 3D, 4D games, animated 3D images, live videos, and even nowadays all the videos we watch on our computers, on our laptop, on mobile phones. So you can imagine the rendering, which is the main computing requirement, which requires lots of computing. The GPU, the importance of GPU, you can imagine that without the GPU is, we will deep dive what the GPU is, but you can say it is a dedicated graphical card, processing card, which actually has its own CPU, much more powerful than the central CPU, and it takes all the load from the main CPU, from the rendering point of view, and all these images, the videos, and graphical activities while you're editing, watching, all are responsibility to render and to show you. This is the job of GPU. Power supplies are very important because the power supplies, the PSUs, these are actually converts our ACs into the DC. Very important, because this without the power supply, we are not gonna work. The computers are not gonna work. Since the birth of laptops, of course, the bigger portion of, especially from when we had desktop back in 80s and 90s, if the electricity is gone, our computer is gone, whatever it not saved is gone also. So if you remember, we used to have the UPS. I remember at that time, late 90s, the birth of UPS and all this stuff, because we want to protect our data in our computers. But since the birth of batteries and laptops, the requirement of direct current is nowadays less. But of course, all the huge computers, we know the importance of CPU, the power supplies and PSUs. Cooling system is also very critical and very important part of the overall computing, because without cooling system, our systems, our laptops, our servers heat up. Heat up means you're gone. It is just like hanging your laptop computers. It will hang and reboot the system if you don't have the proper heating and cooling system in your systems. Finally, we have peripherals, which is the input and output devices. Most commonly, we have USB ports, we have microphone, we have cameras, we have input digital pen, scanner, printer. There are some input devices, there are some output devices. Input device means the devices which is feeding the data into the computer. Output devices, the devices which is actually showing you the result of your computer. You'll go deep dive and see, inshallah, very soon. The next slide. Okay, so let's move forward and look at these components, computer components, one by one. So let's start deep dive into the CPU, the brain of the computer, the central processing unit. So why we call it brain? Because if you look at our body, we have sensors, we have fingers, we have body parts. Once we touch something, we touch the hot things. How do we feel? How do we know this is hot? How do we see? How do we know this is cold? Because of sensors give a signal to where? To our brain. Our brain based on some predefined information. Information can be in images, in definitions, in feelings. The information can be in any form. But the job of a brain is to match based on the sensors information, matches the details of the signal, and then react. Apply the same thing here in CPU also. The CPU responsible for executing instructions from the programs, processing data, coordinating activities between various components. Without it, your computer simply won't function. And how does it work? Let's go deep dive into the component. This is how does it look like. As I told you before, we are trying to make some videos, but we're still trying to reach up, inshallah ta'ala. These same images, by the way, these images are copyrighted on our company. These all are DGO Info license images. We don't copy paste things. And also we strongly encourage you, if you want to copy it somewhere, please give a reference of DG Info, because these are all licensed. CPU, this is how CPU looks like. It has so many components inside. What are these components? Are ALU, arithmetic logic unit, the CU, control unit, the registers, CPU cores and threads, clock speed and performance, the CPU architecture, and clocking, which is the main part of the CPUs. So what are these individual components? How do they work together? The ALU, the arithmetic logic unit. So ALU performs all arithmetic calculations and logical comparisons, whether it is adding two numbers or comparing the values. This is the job of ALU. Control unit, the CU, which is the orchestrates the operation within the CPU. It fetches the instructions from the memory, decode them, and direct the ALU and other component to what to do next. This is the job of the control unit. Registers are also part of the CPU. These are small, high-speed storage locations within the CPU that hold temporary data and instructions. They enable quick access and frequently use information, speeding up the process. You can take registers as your yellow pages, your diaries. If you are a developer, these are the pointers and if you are familiar about the Windows registry, the same concept applies over here. The CPU cores and thread means the modern CPUs. You might have seen, even if you look at your laptop, you will see multiple core or multi-core. If you look at the details of your CPU, then you will find it. So modern CPUs, they are like cores, which are essentially individual processing unit within the same CPU. So once you see the core, don't get confused. They are internal small component which individually process the CPU. So each core can perform tasks independently, allowing for parallel processing. That means a multi-core CPU can handle multiple tasks simultaneously, significantly improving the performance. So if you are electrical engineer, if your background is the BE in electronics, well, I love it. We are actually starting complete 4 years BE program under DG Academy in Pakistan. Very soon we will offer it. We are working on the actually license from the HEC. Once we get it, we will offer it. And it has a specialized program in electronics. And electronic warfare also part of it. It's a specialized training program after this, the BE 4 years. It's a separate not for everybody, but it is, we're going to offer very soon. Core, if you are from a virtualization background, then if you know about the virtualization, you might have seen that physically we have one server only. But once we install the, let's say, ESXi server, which is the hypervisor from VMware, if you install hypervisor, if you install Reddit, which is the virtualization manager, then you might have seen once you install ESXi host server, then you can see the number of virtual machines, the number of virtual CPUs you have, vCPU. Then you are surprised to see, oh guys, we have 56 CPUs. How come? Then what you can do, actually, the virtualization actually takes the individual core as a CPU. Let's say if you have multi-core CPU in your laptop, right? And do you know you don't even use 2 core of a CPU, and you have, let's say, 4 core. If you have 8 core, if you have 16 core of CPU, but you really don't use it, right? So that's why the virtualization invented, and this is how we can optimize the utilization of the hardware resources. Anyways, I don't want to take away our main topic. Our main topic is here about the codes. But if you, because I don't know how many of you have very basic information and how many of you have very detailed and experience in hardware. So I would like to give you a touch base, real world details about, because I teach VMware courses. I'm the VCI, VMware Certified Instructor. So if you would like to take any VMware related course, any virtualization, cloud computing, I can teach you separately, inshallah. All these, they have 36 courses, and I'm licensed to teach all these 36 courses. Anyways, so from touch base, these courses are related to virtualization as well. If you want to virtualize your system, these courses will add value. But what are these cores? These are independent CPUs. And again, what are the independent CPUs? The benefit of independent CPU, the CPU can process the instructions, calculations, the data simultaneously. Parallel computing. If you're familiar with the parallel computing was possible because of the multi-core CPU. Okay, so the CPU supports hyper-threading, which allows each core to manage 2 threads at a time. This further enhances the multitasking capabilities, making your computer more efficient. And I would like to ask you one thing. You can write in the chat window. Which operating system is the real hyper-threading operating system? Real. Anyways, you can write me later. So Windows is called multi-threading, but not in reality. So we can challenge Windows operating system. Linux operating system, you can say somehow reaching to the point where we can say, yes, they are the real operating system, which really maximum support of hyper-threading. They can run multi-core on the optimal level, and also they can run the hyper-threading. They support hyper-threading, and they can really perform hyper-threading on their processes. Again, enhancing the speed, enhancing the completion of the calculation. Clocking speed and performance, it is very important. Why? Because this is why, how do you measure the performance of the CPU? Which CPU is good, which brand is good, depends on the clocking speed as well. So it measures in the gigahertz, indicates how many cycles per second the CPU can execute. A higher cycle speed generally means better performance, but it is not the only factor that matters. Architecture and core count also very crucial role. Why it is important? Because once you're going to buy a server or laptop, you must see it. You must see my CPU, what is the clocking speed of my CPU? Then you can see in the gigahertz. And the most famous is, let's say, now in the old days, they were in the points, man, then 1.4, 1.6, then it came to 2 gigahertz, 2.4, 2.6 gigahertz. And based on your requirement, how do you measure the requirement? This is also very important. How can you say I need that much of gigahertz in this speed? Then this is called capacity measurement. This is, again, it's very lengthy process. So let's come back, stick with the topic, which is you have to look at the clocking speed before you buy a CPU. The CPU architecture, actually, which is Very important. Again, everything is important. Why? Because let's say you are buying a server, you are buying a laptop, and if you want to run, what do you want to run on the system? This is very important. Let's say if you don't know what you're going to run your system and you buy a CPU with ARM-based architecture, there's one x86 series, which is most probably the Intel-based series from IBM, from HP. Most popular servers are x86 series servers. This is what we have. But there is another architecture which is called ARM-based. RISC-V is also ARM-based architecture. ARM-based architecture is different than the x86 series. Some of the applications do not work on ARM-based architecture. So what will happen if you buy ARM-based CPU in your system and you are running, let's say, SAP compiled version, which is for 86 base architecture, then your application will not work. Again, waste of resources, waste of money, waste of efforts, and you might get fired. This is that important. And you can imagine, as I told you in the beginning, 30 years of experience, you have to come back and look at the hardware and the specification. So you must be aware about CPU architecture. Is very important. You have to look at the architecture of your vendor, and you have to look at the need, what exactly you need, which application you're running, and does this application support the particular architecture? No, the most popular architecture are the 86 series and ARM-based. ARM processors are widely used in the mobile devices due to their power efficiency. 86 series in prevalent in the desktop and laptop computers. Okay, let's move forward to the motherboard, the details about the motherboard, the design. This is our beloved motherboard. This is what we have been seeing since our childhood, but we really don't know that. What does it mean? Motherboard, the board which is actually carrying, holding, securing, protecting, connecting all the components, like a mother, the real mother, which actually does the same thing with her child's, with her belonging. Same concept apply. This is the reason this is called motherboard. I'm just thinking loudly. I don't know what was the real adventure behind this name. I did not invent it, so I cannot claim anything. Remember, I'm not joking. I did not manufacture a motherboard. I'm not the one who actually invented in the first place. So I have no right to object why this is the name of motherboard. Look at the vision of DG Info. This is where we want to take you. We want you to think like a vendor, think like a designer, think like a manufacturer, think like a scientist. Again, I don't want to repeat it, but keep it. We will be repeating in the next class. We want to make you think like this. Anyway, so motherboard is the main circuit board that connects all components of a computer. It serves as a backbone of the entire system, allowing communication between the CPU, RAM, storage devices, and peripherals. The main component of motherboard, if you look at this motherboard closely, then the CPU socket, where the socket actually CPU socket is where the processor is installed. So it is part of the motherboard. Once you buy an empty motherboard means there's no component installed. If you remove the CPU, if you remove the RAM, if you remove the storage, if you remove all these peripheral components, then this is called empty motherboard. And then these are all pre-installed by the manufacturing company. But in reality, in old days, the motherboards used to come empty, and it's up to us, or it's up to our service provider, what kind of which brand of component he is installing in our motherboard. So empty motherboard has the sockets. Socket means the place where we actually install this particular component of the CPU on the computer. The CPU socket is where the processor is installed. It provides the connection necessary to CPU, communicate the rest of the motherboard. So this is what we install. There's a RAM slot. You can see And in the RAM slot, we install the RAM disk in it. Most motherboard have multiple slots for RAM because we want to add RAM. Let's say we have RAM stick of 8 GB, and if you want to make it double, so we have to install 2 RAM sticks to make it double. Expansion slots called the peripheral component interconnection express. This is called the PCIs. The PCI actually enable us to add additional components like GPU cards. The graphical cards actually installed in the PCI slots. Very famous network cards are also installed the PCI slots. Storage connectors. This is what the motherboard in old ages where we have SATA drives, hard drives. Nowadays we have SSDs. These all are the motherboard includes connectors for storage devices such as SATA. So there are ports which actually connects the storage. Again, these connectors are connected the storage devices to the motherboard. Chipset acts as the communication hub for the motherboard. It determines how data flows between the CPUs, RAM, and other component. Power connectors. The motherboard has various power connections that supply electricity from the power supply unit, PSU, to the CPU, to the RAM, and other components. We will discuss about the PSU in detail in the next slide. I/O ports are the backplane of the motherboard, features various input-output devices such as the USB, the HDMI, the audio jack. You can see the colorful, the pink one on the left-hand side. These are the I/O ports where we actually connect our USB and connect our audio video input, our HDMI. Nowadays, if you want to connect your laptop to the projector, this is how it connects. I have to be very quick. Actually, we are running out of time. It's very hard to combine the class in 30 minutes. The RAM, what is RAM actually? RAM is a type of volatile memory that temporarily stores data and instructions that your CPU needs. This is what we explained already, but in detail, that how does it work actually? So when we open an application or file from our computer, so the data of the file loads from our storage to the RAM. So this allows the CPU to access it quickly. As RAM is significantly faster than the traditional storage, the more RAM your system has, the more data it can handle simultaneously. So leading to smoother performance, especially during the multitasking operations. Type of the RAMs are DRAM. This is what the most popular is. DRAM means dynamic RAM. It is the most common type of RAM, which is in our computer, laptops. It refreshes 1,000 of times per second. Why? Because this is what the nature of dynamic RAM, DRAM. Again, the data is stored in our storage device, which is your hard disk. And once we load it, it loads in the RAM. And once it is loaded in the RAM, this is how the CPU always interacts with the RAM. Why? Because it has to process the data very, very fast. The SRAM means static RAM, which is faster and more reliable than the DRAM, but it's also more expensive. It is typically used in the cache memory within the CPU. You might have you have seen a CPU in L1, L2, L3. This is what the SRAM is used in our CPU, cache RAM. Then we have DDR, called double data rate RAM. So it has several generations. Those who are from the hardware background, so they are familiar about the DDR3, DDR4, and now we have DDR5. Generation gap, increasing the performance, efficiency, and speed. So RAM capacity are measured in gigabyte. For every task, 8 GB were few years back were the most popular built-in, while gaming and professional laptops and computers require 16 GB or more. High performance systems, let's say if you want to run your virtualization, then it requires at least 32 GB RAM or 64 for the intensive workload. RAM speeds and timings are measured in megahertz, indicating it how quickly it can read and write data. Higher speed can improve the performance, especially in gaming and data intensive applications. Yeah, already have crossed 30 minutes. Let's quickly wrap it up. Storage devices are actually, we have seen it since our childhood. Even if you don't have a computer, you have seen a very tiny little flash drive, USB disk, several type of the storage devices, unlike RAM. So storage refers to the component of a computer that holds the data, files, applications, systems, but it's not like RAM. It's not temporary, it is permanent. So it is a volatile and loses the data when the power off. This is about the RAM, but this one is non-volatile. What does it mean? That if even the power is off, you retain the data in your storage disk. So storage disk are most famous hard disk drives. These are traditional storage devices. The spanning magnetic disk. The most famous of nowadays is solid state drives, SSDs. And there are so many other types. We don't want to go a deep dive, but at the end, for those who are from the system performance and backup system management, they're familiar about the data backup. So data backup, it's very important from system management point of view because this is where you store the data. In old days, we have floppy disk. After the floppy disk, we saw the CD drive, the compact disk, and then we see the hard disk, SATA drives, and then we saw SSD. Now we have USB storage, the external storage, USB small stick. These all are type of storage. At the end, storing the data permanently, and capacity are measured in the, nowadays we have reached to the terabyte, petabyte of storage. PSU, as what was discussed in the previous slide, very important point, because if we ignore the power supply unit, we may go under the power, because you remember the GPU, graphical processing unit, which is very important, which is important for gaming, and gaming is not the only application which requires the video rendering. Nowadays, live streaming the videos, the live streaming the video podcast, the games, matches, footballs, cricket, all live streaming, all live video streaming are also rendered, also requires lots of computing power. More computing, more heat, and more power is required. So the PSU, the measurement of the PSU, is very important because nowadays, because of PSU, it is a built-in part of our system. But what if you want to buy external or backup power supply unit, then you must be aware about the requirement of your system. So PSU is a component that converts the electrical power from your wall outlet to the usable power of your computer. It supplies the necessary voltage and current to all of your internal components, including the CPU, RAM, and storage. So you can look at the picture right now. On the left-hand side, when the power, when the PSU, the power supply unit, supplies this through the red and yellow cable. These through connectors are connected to our storage, our CD drive, our floppy drive, our motherboard, our CPU. These all are connectors, all are coming from our power supply unit. But the measurement is very important because we should know that the requirement of our system and our CPU should be accordingly. Graphical processing unit, the GPU. Nowadays, it is, by the way, we actually don't notice it. We have GPU built in. We have a built-in GPU in our system. So that's why we don't notice it. But if you want to use, the geolocation kind of application, live media streaming, heavy graphics, video games, then you realize, yes, you need the GPU. And also nowadays, the AI, artificial intelligence, that requires GPU. The chat GPT requires GPU. Parallel processing requires the if you know about the weather broadcast, that process too much data, and that also process too much images, the videos, the rendering requires a special and dedicated cards. This is what the GPU can fulfill. So GPU is a specialized processor design that accelerate the rendering images and videos. While the CPU handles generic or general computing tasks, the GPU takes care of the heavy lifting when it comes to the graphics. So that makes it crucial for gaming, video editing, and graphic designing. How does it work? The GPU has built process multiple tasks simultaneously, which is known as parallel processing. It also allows them to handle complex calculation required for rendering graphics. Type of GPU, as I told you, we have integrated GPUs. These are built into our CPU and RAM. Integrated GPUs are suitable for every task, lightweight gamings. This is all. That's why we don't notice actually we all have integrated GPUs in our system, in our laptop. But for external use, we have dedicated GPUs. These are the separate cards installed in the PCA slot. This is what we see. We have seen it in our previous screen. Again, the features of GPUs are VRAM, which is called video RAM, clock speed, which is measures in megahertz and gigahertz. The cooling, we should have a separate and dedicated GPU cooling system also. Why? Because it generates too much heat. So in a summary, the graphical processing unit is a vital component that drives visual performance in your system. Understanding its function, features, and types are very important for you before you buy any other critical system. Cooling system, as I told you, that cooling system is very important, because if we don't have cooling system, then your CPU will get burned, will lower the performance, slow down the CPU operations, and also the intense calculation processing, which is the GPU. We should have a separate fan for the GPU. Overall, if your system is not it's not running an application which is highly CPU intensive or GPU intensive, then the normal fan of your system is enough. But if your requirement is to process too much data, and if you are running applications which requires very intensive processing of your CPU and GPU, of course, it's generating too much heat, then you should have a dedicated fan. As you can see on the screen, we have sink, we have heat sink, and on the heat sink over we have a fan, which actually reduce the heat of your system. We have air cooling, liquid cooling, all-in-one liquid coolers. We have custom liquid cooling loops as well at the end to lower the heat of our system. Input-output devices, as I think I already explained it, but we'll just quickly go through it. The input devices, which is to the devices. Input devices are hardware components that allow users to send data and commands to the system that enable interaction and control, transforming the user action into the signals that the computer can understand and process. And output devices, what are the famous input devices? Keyboard, mouse, touch screen, microphone, scanners, these all are the input devices. Output devices are hardware components that convey the information from the computer to the user. They display, print, project data, allowing user to receive feedback, whatever we have done in the input devices. Now, this is our last topic, which is about the casing and chassis. If you are end user, doesn't matter because these all are all assembled. You receive a system assembled. But if you are working in a company where this is your job, or if you are part of the maintenance department within your company, and if you are part of, let's say, manufacturing company, sizing, the gauging, each and every thing requires very careful measurement because any small inch difference may cause a big failure of your system. Big failure means does not like system not going to work. System will not be installed in your system accurately. And if you try to just install it, assemble it in your system, which is not accurately designed for this particular chassis or cases, then you will end up with lots of issues from security protection point of view. Let's say if your case and chassis are misfit, and let's say, and you might have seen multiple times before, your case does not have a floppy disk or a CD drive, and you have to install it and you have to use your CD drive, then you actually have to cut your case and chassis. At the end, you are going to damage it. So proper casing, measurement is very important, very crucial. It is casing and chassis are for the protection. Also, well-designed case enhance the airflow, which is very important for CPU and GPU. And case provides a structured layout for the cabling management. It makes easier to keep your build tidy, good organizations. These all are very important. We have different type of cases. We have full tower case, mid tower case, mini tower case, small form factor cases for small CPU, small systems. The things need to consider is airflow, the expansion objects, cable management, the quality. And if we summarize it, so you can say it in a summary, the case or chassis is an essential component of your system, of your computer, that provides protection, cooling, organization, and choosing the right case can enhance your overall experience and ensure that your components are well supported. Okay, guys, this is done for English type. We are over 18 minutes now, and I'm sorry about it. Maybe I added some extra things within my lecture. That's why we are at 18 minutes more. I will open now the. Okay, guys, you can ask me any question. You have 2-3 minutes to ask any question, please. Any question you have asked, you want to ask, you can ask me now. You can unmute yourself. You can raise your hand. I will unmute, or you can. Now I have allowed you guys to unmute, please. You can unmute yourself and you can ask me any question. This recording will be uploaded on a YouTube channel, so you can just watch it. If you have any questions, you can even ask this question on our YouTube channel against this particular video. We are starting our Urdu lecture. If you want to stay, you can stay here without any problem. If no, you can leave. Thank you very much for your participation. I'm just ending the English session so I can upload this as separate. Okay.